Okay, we've just been working on this in class, and we've been trying to figure out what the correct numbers should be, or what the correct solution should be to get in and solve this problem. In this problem, we're given a blue solid, and the blue solid is found to contain 36.84% nitrogen and 63.16 oxygen. So what is the empirical formula for this solid? And by the way, the empirical formula for this solid is most likely going to be the molecular formula, but I don't know that for sure. So let's look and see what was done first. Okay, the student had calculated, first of all, changing the molar mass, and so here's the molar mass of nitrogen in the atom. Here's the molar mass, or the mass that we got from our sample. And this works out to 2.630. And you're going to see that I drew in that same number underneath, because we need to change the smaller of the two numbers that we get. See, when we did the same operation for oxygen, we wound up with 3.948. And you notice there's a lot of sig figs. Don't get rid of sig figs on these problems. It'll lead you to the wrong answer, or you'll be questioning whether or not you got it right. So keeping the sig figs as much as possible is a good idea. And so down here, when I divide this guy by itself, that gives me 1 mole. So no matter what I multiply this guy by when we get the answer, it's going to have an even, or not an even, but a whole number for the nitrogen. So down here, what we've done is given you the answers of these two divisions. And let's take this guy down here for this one, and this guy up here is for this one. And the different colors help you see what those are. Now, when you look at that answer, what you're going to find is that multiplying this and this by the same number, which is 2, so I got a little interruption, but let's continue. As I take the lines down here, you see where the numbers are when we divide these guys out. And so we got a 1 to 1.5 ratio. And when you rewrite the ratio this way, you can see that when you multiply both sides by 2, you wind up with a 2 nitrogen to 3 oxygen in small whole number ratios, which is what we're all about. And that leads us to this. So what the student had done is left out this step where you see my blue writing. Didn't take that through to this and then lay it out like this so that they could see that we were talking about a ratio of nitrogen to oxygen of 1 to 5. And the multiplying and bringing it up here. And that's how we got this one solved. Another problem that gave most students a lot of trouble was this one, number 48. Now 48 was, we're given carbon, and these are the grams, and we're given hydrogen, and these are the grams of hydrogen. Okay, what are we doing? We're simply dividing by the molar mass, which is what these calculations show. One thing that I'd like you all to do, if you're not doing it already, is to be sure and put your given over 1, like I'm doing here. Given over 1, just treat it like any other calculation. And these numbers are what carry over into here. And what the student was doing here, and correctly so, dividing the smaller of these two numbers by itself. And what that does is it gives you 1 mole of that particular element, in this case carbon. Now over here, we're dividing the hydrogen, the moles of hydrogen that we got, by the same number. Because if we don't do the same number here, we're going to change the ratio of the elements. But as long as we use the same number, the ratio does not change, whatever that ratio looks like. So this number is working out to not be an even number. So what our challenge is to multiply this guy and this guy, in this case 1 and 2.648, by the whole numbers, and that would start with 2. So what we did down here, and you can just kind of forget what the student did in here, he got a little confused. So we're going to just continue on down a little bit. So when I multiply this stuff by 2, we get 5.296. That's not close enough to a whole number. This dude is really close. And quite frankly, when I got here, I considered pretty much that we were done. So with this guy here, 7.94, you're really, really close to 8. Not as close to 5 as this number is. So the goal here in multiplying by these numbers is to get a number that's as close to a whole number to make our ratios work. Now, I went ahead and did some more to see if we could get one that was closer. Here we're off by 5, almost 6/10 from a whole number. And here we're off 2, about 2.5 from a whole number, 0.2.5. So my bet would be right here. I didn't go any further, and this, of course, is going to give us the correct answer. But how we got it is most important. So this value, as it says here, is closest to a whole number. And I was trying to give an explanation over here of why we did what we did. So we're multiplying by larger and larger numbers until you are very close to a whole number. And I just kind of got a little doing a little bit of extra work here, just to be sure. Not required, but when you're that close, you're pretty sure you got it. Now, if you go to today's PDF file on the whiteboard PDF from my website, I've got all of these guys listed. They all show, all that we went through was these last two because they were the most difficult. It seemed from polling all my classes that these guys were pretty easy. This particular problem right here, one of my students from first period had made a error, and I'm glad he did it because by doing that, it showed the importance of the subscripts. This was all that he left out, and his whole thing was wrong. Nothing worked. Okay? So what happens is when this 2 got added, because this is calcium, which has a 2+ charge, and chloride has a 1-, so it has to be 2. And of course in the book it's written with a 2 subscript. So once we substitute the 2 in for the chlorides, that changed this number, which changed this number. Okay? And then when I divided this number out, of course it changed the result of this calculation as well as this calculation. So it has a ripple effect. And so don't get off on your subscripts. Those are the easy numbers. Make sure you don't miss those. And that's it, folks. You can view these on my PDF file at your leisure and make sure you understand them, and life is good. You'll be up to date on what we're doing so far. Thanks for watching.